My name is Kalle Eneroth. I'm the CTO of the Swedish Sigfox operator. We started 3 years ago by planning and ramping up for a massive rollout, build-out of the global IoT network, which is called Sigfox. Sigfox is this low-power, wide-area, technology-based operator, which is global. It is the world's largest dedicated IoT operator. It's present in 50 countries. It's going to be 60 by the end of this year. Sweden was number 32 for building out the network. And that makes us the largest dedicated IoT operator in Sweden. Today, we cover 60% of the Swedish population, 23.3% of the landmass, and we're growing. We've rolled out so far about 100 radio base stations. And when we're done, approximately a year from now, we're going to have 400 or 450 radio base stations covering the country. Now, it's important to notice here then that the low-power wide area technology really enables a new type of market for IoT communication. We're not talking about bandwidth or high data. You don't stream audio or video on this network. You send small pieces of data. With the Sigfox technology, it's up to 12 bytes maximum as payload. But there is a massive demand for this type of communication because it enables certain things through its design that we'll come to a little bit later. Another thing that is also really important to note is that we are an operator. So we sell subscriptions in this network. We build a telco-grade, or a carrier-grade network by placing our antennas on an optimal height in order to pick up as many signals as possible. All of the devices that communicate in this network, like this little bad boy, for example, a GPS, Wi-Fi sniffer, accelerometer, and BLE chip inside, they are all certified formally. And this is a mandatory process that you need to go through in order to be able to commercially communicate in the Sigfox network. So this is done centrally in France at the Sigfox labs. All of this we do to build quality in the network. We build a network for generations. And with this, we can guarantee globally that we have a 99.5 availability where you have the Sigfox coverage. We build for 99.7, but we guarantee commercially 99.5. Another really interesting aspect of this, given that this is a global network, there is no roaming. It's one contract, one network, one subscription. So if you buy this one here in Sweden with a Swedish Sigfox subscription, this will work all over the world. Those of you who know a little bit about the ISM band, because this is a sub-gigahertz band, in Europe, parts of Africa and parts of the Middle East, it's the 868 megahertz bandwidth that we're communicating over. This is a military frequency in the US, so you go to jail if you start communicating without there. So there we use the 902 megahertz instead. In South America and in Asia, we use 920. But there are also solutions to be able to technically determine which network do I belong to right now so that you automatically can switch between these. It's a solution called Monarch within Sigfox. Now, with IoT, it's fantastic. This is really applicable everywhere, in every segment, in every industry. When I started working with this, I couldn't be productive for several weeks because I simply couldn't see the trees because there was a forest standing in the way. What we usually look at when we start looking at these types of solutions are two things. Either you want to optimize your existing operation, your existing processes, and thereby gain cost reductions. Another path to take is to generate new value streams, new values that you can bring to your customers and thereby earn more money on it. Just to take one example, there's a utilities company here in the Nordics that has 2,000 dams. And they have sensors, existing sensors there, that measure the pressure of water to determine the level in these dams. They have a GSM modem today that is communicating the data on a regular basis, but it's just small sensor data, so you don't really need, it's a little bit overkill to have a GSM modem for that or communication for that. They need to change the batteries on these modems 2 to 3 times per year. So there's one entrepreneur in the north of Sweden who has really said, no problem, I'll take care of this. I'll do this. All the 2,000 dams and devices all over the Nordic region, I'll take care of that. And it will cost you this much per dam. So they have a cost, this utilities company, of about 1.5 million per year. Right now we're running a pilot where we show that if you put a small Sigfox sensor, you keep the existing sensor, but you just retrofit a new communication path with Sigfox. We can come down to slightly above 2,000 SEK per year, because then you have a battery lifetime of over 10 years. That's those rare moments where you see ka-ching in the eyes of the customer. We have our legacy networks that are really important and are good for various things. If you're going for smart cars, for really mission-critical applications where you need to have real-time data, large volumes, then this is not what you should do. But there are so many municipals or companies or industries that have been wanting to hook up maybe 2 or 3 million devices instead, or objects. Then this is just not good enough. It costs too much. It costs too much to maintain. The devices are too expensive. So the whole idea with LPWAN in general, but Sigfox in particular, is to open up for the mass volume IoT business. And this is going to be a real game changer moving forward. So looking a little bit, taking a comparison then on the 4 main pillars. With Sigfox, we are cost efficient, we're energy efficient, we have a global reach, and we have simplicity. If you compare to the legacy networks where you have LTE, which is really great for streaming video, for example, Wi-Fi, likely so, the Bluetooth and Zigbee, more localized networks, but also really, really good. But they really do not perform on all of these different levels in the same way as an LPWAN network does. And looking a little bit closer to this, we have a really simple solution. Every tag, if we look at something to just track positions of objects, every device has a hex code, 6 positions. It's globally unique. So with this, we're actually moving away from plug and play, because this works right out of the box. You simply just register your code if it hasn't been done already in the factory, and then it works. When I send this to my partners or customers, I give them the dashboard access before I put it to the postal office, and then they can follow it all over the world down to their position. It has the global reach, meaning that with 50 countries and growing, the manufacturers of devices that want to connect them and be able to communicate the data from them, if they choose a technology like Sigfox, they overnight tap into a global market of 50 countries. Again, no roaming. I go to a lot of these different kinds of IoT events, and I hear a lot about different types of industries within logistics, within construction, within e-health, and they all say the same thing. When they present their pain points, they really almost literally describe the whole point with low power wide area network and Sigfox. Energy efficiency and low cost, not only for the traffic, but also for the actual devices. This tracker costs a little bit dependent on volume and what technology is in it, from maybe 250 Swedish crowns to 500. It wasn't that long ago that a GPS cost more than 2,000. Depending on the battery life, this one, again, this is completely closed in plastic. And with the small battery that you have in this one, you can send 14,000 messages. So if you do the math on saying a couple of messages per day, you see that it's several years of runtime on this battery. We're really seeing that the floodgates are opening now. The market is, since this touches on all markets, the maturity level is very different between the different verticals, but it's really something that is happening now. We have an institute here, the Machina Research, who estimates that in million number of low power wide area connections, we're going to end up here by 2024. Right, so let's look a little bit about how it works. I'm actually not going to get that much into technical details, but I'll be here all day. So if you're curious, then come and grab me in the coffee break and I'll explain a little bit more. So basically, we have your sensors, your trackers, whatever it is that is sending the data. They're sending it to our networks, our base stations. We are backhauling them to a back-end system centrally for the entire global network located in France in various locations. There, it's pushed out, either pushed out or pulled to a target system of the customers. So basically what we do, we just transport the data. It's a two-way transport, and it's important to point out here that two-way with a bit of a modification. In order to save, primarily, in order to save energy, you want this device to do as little as possible over the course of its life. So when it comes to the downlink, I mean, it sends data when it wants. But when it comes to the downlink, the device itself sets a flag saying, I will now listen for 30 seconds for something that the network wants to tell me. That's the downlink. This would typically then mean that you can get configuration changes, new pieces of information that the device needs to operate in the fashion that you want. It's up to 12 bytes only, the payload, in uplink. In downlink, it's only 8 bytes. And due to the fact that we are communicating over the 868 megahertz ISM band, industry, science, and medical, there are regulations in all parts of the world. For the EU directive, it says that you're only allowed to use 1% of the duty cycle. So that means that we will only be able to send one message every 10 minutes. A message is always sent 3 times, 2 seconds per message. So if you break 1 hour down into 3,600 seconds, 1% of that is 36, and there you have your 6 messages in an hour. For the downlink, you're only allowed to have 4 messages to the downlink. So this one, for example, when it wants to get a position at a predetermined regularity, then once per day this one sends, okay, should I change my default 4-hour interval to something else? If yes, then we have configured that, and then every 24 hours you will be able to make a change. Everything in the design of this technology has been focusing on lightweight when it comes to energy consumption. I don't need to tell you guys that an IP header is 40 bytes. For the Sigfox communication protocol, it's 14. I mean, with IP, it doesn't matter, because if you're sending more than a kilobyte in data, the overhead is really relatively small. But since our payload is up to 12 bytes, we have to have really small bandwidth. If you're looking at other more cellular technologies, like narrowband IoT, for example, They are also very energy efficient, but there is a slight challenge with the fact that they need to go out and negotiate for a communication path. They need the throttle in the network. So there's a lot of signaling traffic that goes on, which obviously then eats up a lot of energy. So all of this we do in order to prolong the battery capacity of the devices. Again, remember the dams. This is really something that constitutes a serious cost business-wise. So 12 bytes. What can you fit there? Well, one GPS position is 6 bytes, so you can fit 2 of them. Or you can come up with something smart that you only take a delta position or something so that you can fit more than just one. You can also do 6 measurements of temperature between -200 and +200 degrees, for example. Or maybe something else like a speedometer or CO2 levels or whatever you might want to do. Maybe you just want to determine if something is open or closed, 1 or 0. Then you have 96 positions all of a sudden within one message. And then, very common and very useful, just sending a small ping, saying that in an alarm situation, for example, where you want to put this on a work shed that no one ever uses, but you want to have it covered for 10 years. You need to make sure that this guy has it under control. So every 24 hours it sends just an empty message saying, don't worry, I've got it under control. So why do we do this? Well, you shouldn't send more data than you have to in order to, again, save energy. Right. If you start looking at IT, you will quite soon you will get into discussions around ecosystem. So what is an ecosystem then? Well, it's everybody who makes part of making this work. It's the chip and module vendors, both for sensors but also for connectivity. It's the device makers that takes these chips, puts it on a board in a nice casing with the right proper antenna, and then sells it as a solution. You got the connectivity providers, the likes of us, the likes of you guys building the backhaul that we are communicating over. The platform providers, the ones who are doing the AI, the data analysis, the machine learning, the presentation of the data into an operator, what comes out on the other side of the Sigfox network, in our case. And then you got the vertical application. You got the e-health people, the smart city, the ones who are really experts on their niche, their vertical. I'm a strong believer in that there is no one company that can provide this, the whole echo chain. There's no one player that can do this. There are a few foolish attempts from some companies, like my previous employer, Ericsson, loves to be all of that. But what I see now in the market is that we really need to find new, smart ways of working together. When I'm looking into this, I don't have time to copy what others are doing. There are so much new stuff to do. So if a customer comes to me and asks me, I want to do this, then I know, you do that. So then let's go together and we have a smart partnership instead, so that we can focus on doing what we know that we are good at. And with the fact, again, then, that it is such a wide market, and it's been around for 8-9 years, it has had time to grow. There are almost 1,000 commercially ready solutions, end-to-end, communicating over the Sigfox network. And we're not talking about small players here. Just a few weeks ago, it was announced a partnership between Sigfox and Bosch Siemens. So by the end of this year, all of the Bosch Siemens equipment that comes out of the factories is going to be Sigfox enabled. Also with one of the largest companies, Verisure, has their home alarms connected via Sigfox. And there's much more coming. Just in January, a 300 million euro deal was struck with the government of China in order to build e-health solutions in larger cities in China. And then that means that the network is now going to be built also in China. And that, of course, will be a catalyst for the entire ecosystem in building new and cheaper devices constantly. So just to take a few examples. Like I said, Verisure. This is the Verisure home alarm system. It's one of Sigfox larger customers. They have about 1.52 million subscriptions something in the network. They have as their first line of defense the local IP network. However, it's very easy to just cut that cord, or maybe the customer themselves do that for the burglar when they go on vacation, for example. The second one is an autonomous GSM modem. You can get equipment for 100 euros on AliExpress. Well, 100 euros plus 75 crowns these days. But to just jam that out. Third line of defense, Sigfox. Since every message in Sigfox is sent 3 times, and it's also randomly spread out over the bandwidth that we have, or the spectra that we're operating within, it takes a tremendous amount of energy in order to jam this. The way that we actually won this deal was that Verisure themselves, they placed all of the jamming equipment that they had in their own labs around the conference room. They started it, and then we have one of these big buttons that first blinks red until the message goes out and comes back, and it becomes green. If we press this and it becomes green, we sign the contract. Those 13 seconds, I think, that it took to come around was quite nervous, but eventually it turned green, and we got the deal. A second really interesting case, and this is the fun part. I mean, I'm a computer scientist. Who knew that I would start working with trains, with home alarms? You can't imagine how poorly the wagons pulled by trains are monitored today. We actually found a farmer in the south of Sweden on a stick track somewhere forgotten who had 2 of these wagons. And he used it for storing his firewood. And these are several million each in value. Anyway, so trains running around Europe are now monitored with similar devices like this one. Every device, almost every device that has a tracking function has this accelerometer. Naturally, because since we're chasing energy here, we don't want to send data when we don't have to. So if this one lies still, you shouldn't be communicating with it. So you only want to send a new GPS position when it's in movement, right? So the accelerometer is really important. Now the thing is that this was great. They really got a good logistical flow. They saw where their carts, their trains were at all times. But they also found something else that they had not accounted with. And that was in certain places, whenever a train went by, every cart that had one of these gave an extra bump from the accelerometer. So they got some service engineers out to these points, and yeah, of course, there was something wrong with the tracks, something that needed fixing. And you can imagine then the value just from finding that information without having to search for it yourself. So a lot of various side effects. Another industry, cows, connected cows. We have a bracelet that we put around the neck of cows. And the idea here is that every 21 days, the cow is in heat. So in order to get calves, she needs to meet then a bull, but well, these days it's more a veterinarian, I guess. But you have 14, 15 hours of window to make this happen. Then obviously, if you have a stock of, I don't know, a couple of thousand of animals, it will be very difficult to keep track on that. At the same time, you can also measure certain vitality measurements like temperature and things like that to make sure that your animals are okay. But it's not that gives you the indication of when it's time for the vet to jump in. It is the movement of the cow. It moves in a certain pattern, which we can determine with this tracker. And that is how you know that it's time. Another prestigious project for Sigfox, and this was one of the early ones, was rhinos, in a national park in Kenya, where they had tremendous problems with poachers who were killing these animals, illegally, of course. So they put, again, a similar type of tracker where you could see the location of the animal. Animals, they often run around together, and you could also measure the stress level of the animal. And when these two gave the right combination of indications, you could send out the security people out there. In the best case, you would actually be able to detain the poachers who were there. In the worst case, at least you managed to save the lives of the animals, most likely. It was very successful. Again, not a mass volume, but it really illustrates a very good point of this type of technology. Anyone like beer? A beer never tastes as good as if it has been monitored by Sigfox communication. In Spain, in France, in Portugal, every beer from tap is actually, with very few exceptions, is actually monitored via Sigfox connectivity. What they do, they measure the levels in the kegs, but also the temperature in order to have the control and quality of it. I'm actually a trained sommelier these days. I got a golden ticket from Ericsson once, and I managed to jump on a sommelier training. So I'm a little bit more into wine. And there is this company, it's two guys who exited NASA. And they're operating from Silicon Valley and from Linköping here in Sweden. And they have a very nifty solution. They have sensors that measure various environmental climates in the ground. They have low-flying drones collecting data, and then they take satellite imagery on which they build a three-dimensional topology view. Then they build an information cube so that they can then make certain decisions informed on how to progress with the production in order to maintain the quality, but also perhaps the character of the product. They are working with agriculture in general, but with wine production in particular. And no wonder, because I don't know if you've heard this, but within a vineyard, from here to there, it could actually be two massive differences in the microclimate. And this is tremendously important if you want to really keep producing that character, to have that under control. So they have about 4 pilots now around in Portugal, in Hungary, in Turkey, and some other country. But also, of course, they are monitoring the Swedish strawberries that are being produced outside of Nyköping. Right, so just a reminder then on the importance of this new type of technology. We have the energy efficiency, priority 1. Closely after that, you have your cost efficiency, both on the device side, but also on the connectivity. This is needed for mass IoT, mass volume IoT. Then the simplicity. It needs to be simple to apply this. And then finally, we've got the global reach. This really works seamlessly over the entire world where you have the coverage. Thank you.
Okay, hands going straight up in the middle there. Oh, sorry.
Mikael Abrahamsson. So how does this scale? Can we have hundreds of millions of sensors in the Stockholm area?
Yes.
Can they sit in the basement where there is normally not even mobile coverage?
Yes.
Okay. With your current rollout, or do you need to do more?
No, what we're doing is that we have had a strategy where we have built an umbrella coverage, first of all. We want to cover as large parts of the population where they are and where they move, because that's where we see the initial business. Like I said, we've built about 100 base stations now. Last fall, and we've done that in a little bit over a year. We've built this coverage. So what we had started doing, we met with a critical point or critical mass in terms of land coverage, where we also started in parallel to densify. So we are currently now densifying the network. We're working closely with Terracom using their secure sites for this to also get the carrier-grade type of network up. When we are done, most parts of Sweden will be covered with at least 3 base stations. And when you have that good coverage, what you will see is what we call the deep indoor coverage. Since we are working on a sub-gigahertz frequency, you have a very good penetration. So we actually can come down to 2 stories underground, 2 floors underground with the technology, if you're close enough to a base station. But most places will be.
Okay. And when I said hundreds of millions of sensors, is this sensor sending 1 message per day or 2 per year, or is that actually something that talks hourly?
No. The limitation here is 140 messages per every 24 hours.
Per device?
Per device, per
okay.
radio unit.
Okay, so you could have 100 million devices in Sweden, or let's say in Stockholm,
yeah.
100 million devices sending hourly messages.
Yes.
Okay.
Absolutely. And also on that note, every base station can actually handle several million of messages within the same time frame. Just to comment also a little bit on this, my mother-in-law was visiting last summer, so I went to Helsinki and I chose to take the boat instead of the flight because I wanted to prolong the trip. Anyway, I was sitting there, I was meeting with one of our partners, Tieto, and I was sitting early in the morning, started preparing my presentations. I was in the middle of the Baltic Sea, just between Stockholm and Helsinki. And I took out my field tester that I always carry with me, and I checked. Oh, shit. We've got minus 112 dBm. That's really good coverage. We can pick up signals down to minus 145. So I took out my phone and I took a picture of this to send to my colleagues here in Stockholm. And then, okay. I had to wait for 3 hours in order to get GSM coverage in order to send the text. So it's really potent. Sorry, more questions.
Okay, we had one at the front, and we'll have one from Marco, quick one, and then front, and then we have to break for lunch, I'm afraid. So Marco first.
I'm not sure whether it's a quick one, but in line with what Michael said, and the big elephant in the room is kind of decommissioning. We're now looking at self-harvesting devices that might ping forever. What is Sigfox strategy to ever get these devices back? Or is it basically just toss them in the field and they will be beeping for the next 100 years?
Yeah, I see. Because one of the things that we are looking at, I mean, you want to choose, of course, your applications soundly so that it brings a value and does not impose any threats in any way. For example, what we are looking a lot at right now is disposable devices that can be biologically taken care of just by throwing them away. So zinc batteries is a really hot topic right now. I myself am looking a lot at these one-use tags, just a sticker that you put on a box and you can track it then all over the world. I also, there is also a triangulation possibility between the Sigfox networks also to get a rough position of where an object is. But sure, sustainability is really high on this topic, but I think that we can really, with this technology, save a lot of resources. Yes?
Okay, last question at the front.
So you're sending pretty short messages, and so how do you sign the messages? How do I know that the right cow is sending the message and it's not the hacker?
Yeah, okay. First of all, everything is encrypted. So you have a unique encryption key in the device that only the manufacturer has. Then the fact also that the device itself determines when to listen. Oh, okay, so you mean the uplink data? Yes. Yeah.
Yes.
Yeah, but that's the encryption. And the device IDs is something that only the owner of the solution has. So the network will not accept anything that is not from that particular device.
How about a replay attack?
Yeah, sure. I mean, nothing is perfect. I should really not say this. I was just about to say the network has not been hacked yet. That's like inviting people for it.
What is your door prize?
Sorry?
I feel that the alarm company people were incompetent, right? So.
No, but if you look at other technologies such as for example 6LoWPAN, which is another LP1 player.
You're changing subject.
No. They have IP all the way out to the device. We don't.
Okay, but I asked sort of so how big was the address? You said 6 bytes or 6 hex?
It's actually 8 hex. It's a hex code of 8
so
positions.
It's 8 4 bits?
Today only 6 hexa characters are used.
So there are 8 4-bit slices, so it's 4 bytes.
Yeah. No. It's a hexa. Yeah, sure. Okay, sorry. Yes.
Hex is 4 bits.
Yes, exactly. Yeah.
How many bits is the address?
Sorry.
How many bits is the device address?
The address. It's then 4 times 8.
4 times 8. That doesn't make 100 million.
Exactly. All right. I'll email you the answer to that.
Okay, I'm afraid we've reached the end of the session. Could you please join me in thanking Kalle for a very interesting presentation?